Today we are going to discuss IstructE problem. That is, you can find those problems in the structural quiz. So this problem is related to truss, this pin jointed truss. And so firstly, if we first of all we need to find out what structural form is this, what kind of truss is that. So for your information, it is spread truss. Just in case if you see such form, you can just quickly identify it as a bread truss. Coming to the problem, what are the things that are given in the problem and what are the things that we need to find out. The first one is we need to find out the maximum force. I will come to this later on. The other thing is that this is pin jointed, so all the joints that we see in this truss are pin joints, that which implies that at all this location the moment is 0. We need to saying that we need to find the member force, whether it is in tension, whether it is in compression, and the diagonals are at 45 degrees to the vertical. These are the diagonal members, so this angle is 45 degree. Now since the angle is 45 degree, that means if I assume that this length is L and all these members would be at equal spacing, so they haven't mentioned that, but seeing the picture, we can say that all are at equal spacing, and this would be then 10L, and based on the simple geometry you can say that this is also L, it's 1045. And other thing is that so firstly we need to figure out what they mean by the maximum force. If you see this particular structure, and we can just make an analogy. This could be a beam, right, of length 10L. Okay, so this would be 10L, and we have some point loads at 3 locations, and we have support over here. This is roller support and this is pin joint. That means that it can take horizontal forces. So if you see, where would be the maximum stresses, bending stresses in this beam? At the midspan, at this location, there would be sigma c would be maximum compression stress. This would be maximum tension stress. If we have this maximum compression stress at top and maximum tension stress at bottom, that means that maximum forces we're going to find at the top and the bottom, which means these are the members that we need to focus on. Okay, this is one thing. First we sorted out this where we have to calculate the forces. The very first thing that we need to find out is reactions. Now it's very easy to calculate reactions. The first thing that will come into anyone's mind would be, I will take the moment about this 0 and we will calculate the reaction taking the lever arm of forces, and we can get the reaction. You can do that, it would be simpler. The other way is to divide the structure into 2 parts. That is, one is this. Here we have 3 forces, which is 90, 150, 90. we have support, let's say A and B. The other would be remaining 110 minus 90, that is 20. It's 20. The distance would be this would be 2L, and this is again A and B. So the reaction in total at A and B would be the summation that we get from the analysis of each beam. Since this is symmetrical, we can add this forces and then we can just divide by 2. So this would be 90 plus 150 plus 90, that's 330, and that's divided by 2, it would be 165 kilonewton. This would be same as 165 kilonewton. The other way is to this is very simple. Since this is 2L, let me mention here. So this is 8L, this is 2L. So RB here would be 20 into 8 divided by 10. That's 16 kilonewton. So RA would be 20 minus 16, 4 kilonewton. So RA in total is 165 plus 4, that's 169. You only need RA for now, but I'm just writing out RB as well. 165 plus 16, that's 181 kilonewton. Simple, the reactions are okay. Now we have to discuss member forces. So I'm going to make this arrangement. There's 5 panels, 2, 3, and let's do 5, we don't have to draw. Now these are the support at this location. Here we have 90 kilonewton. This is 169, sorry, Newton. And you have some diagonal members. You have some diagonal members like this. Okay. Here as well. Now since we know that at the top member there would be compression force, so there's the sign convention that I'm drawing for the compression and that you need to remember is the compression, the forces would be in this form, tension, the forces would be this. I will take that separately in other videos, but for now just take these members. Okay, this is tension, so the member would be like this. Okay, yeah. Okay, now so you have to take moment about either at this point or from this point. We can take from anyone, but we can't, because if we take about C, they are diagonal members and we won't be able to find anything from a single equation. So the best way would be to take the moment about D. So the MD would be 0. That means that let's say is force F, and we are taking on the moment about D. So 169 into 5L, because this is a clockwise movement, let's say clockwise positive 5L, and 90 would produce anti-clockwise movement, that is negative 90 into 3L. Again the force F would be anti-clockwise, F into L. Summation would be 0. So based on this, F is 575 kilonewton. since f is positive and we have assumed that's compression first, and based on that we have just drawn this force diagram. So that means this compression that we have assumed is correct. Now we have to check what are the options we have. So we have 575 in compression, that's okay. And yeah, so we are going to have some more videos based on this, because this will actually increase your basic skills, and then we will move further and we will analyze more critical structures, just like bridges and building structures. So after some videos, when you say I will cover all the forms, and then later on we can work on a whole structural form like bridges or buildings. That's all for today. Thanks.